Hi, we're going to continue with alternative limit evaluation techniques. We've already covered simple things like looking at the graph, doing it numerically, and then we moved on to the basic limit laws, such as the sum and difference rule, the product rule, or law, the quotient law, direct substitution, things like that. Then we went to alternative limit techniques, which involved finding a function which agreed except at a point, and doing something like factoring and canceling or multiplying by the conjugate and canceling. So now we're going to keep rolling forward with that. There's something called the Squeeze Theorem that we're going to introduce, and let's go to writing mode. Okay, so this is best explained with a picture, so let me insert a graph. Okay, so here's our axes, here's our x and our y axis. Okay, and then I'm going to draw in two different functions. So this one right here is going to be f of x. And then this function is going to meet right there and then go down. This is going to be my h of x. So imagine, so what we have so far is we have our f of x is always greater than our h of x. So our f of x is less than or equal to h of x. Now imagine there was a g of x between them. So g of x is like, I don't know, over here doing something, and it has to be between them. And let's say that this point where those two functions f and h meet is x equals a. So we know that the limit as x approaches a of f of x is equal to the limit as x approaches a of h of x. Definitely their limits are equal because they're equal to each other at that point. So if we have decided that g of x needs to be between them, g of x basically gets squeezed, and that's why this is called the Squeeze Theorem. So if you have these two outside functions, the f and the h, and if their behavior is the same as you go to a, in other words, their limits are equal to L, then the Squeeze Theorem says that the limit as x approaches a of g of x is also equal to L. So g of x gets squeezed between the two of them. So let's do an example of this. So we're going to compute the limit as x approaches 0 of x times cosine x. Okay, so a lot of these problems involve a cosine or a sine or something like that. And notice the Squeeze Theorem only applies basically when you have a triplet of functions and there's an inequality, like f is less than g, which is less than h, and then the outside ones go together. So your first step usually is to create that inequality. So this is going to be our g of x, the function in the middle. Usually what you do is you start off with the fact that cosine or sine, usually there's going to be a trig part, is between -1 and +1. Now notice cosine x isn't what we want x times cosine x. But the whole point is that because cosine is between -1 and +1, it starts the inequality. Now what we can do is multiply by x, and we get minus x is less than or equal to x times cosine x, which is less than or equal to x. This in the middle is now our g of x, and we have on the outside our f of x, the bigger one, h of x, the smaller one. So the second step is we need to verify that the limit of the outside functions f and h are the same. So we calculate the limit as x approaches 0 of f of x, which is equal to the limit as x approaches 0 of x, which using direct substitution is just 0. And we could do the limit as x approaches 0 of h of x, which is just the limit as x approaches 0 of minus x, which by direct substitution is also 0. So because they are equal to each other, we can now say by the Squeeze theorem, the limit as x goes to 0 of g of x, which is x times cosine x, is also equal to 0. And we're done. Thank you for watching the video.